All right, let's just get right into it, shall we? We constantly hear people comparing the human brain to a computer, basically assuming it perfectly records data and runs these absolutely flawless calculations. But what if I told you that is a complete myth? Your brain is absolutely not a perfect computer. Actually, it's a highly efficient, sometimes deeply flawed categorization machine. In this explainer, we're going to decode exactly how your mind works, pulling straight from an incredible breakdown of 85 core psychology concepts. We're going to look under the hood of your own cognition, figure out exactly why you make the predictable mistakes you do, and best of all, give you the actual cheat codes to upgrade your memory. So here is our roadmap for today's explainer. 1. How your mind thinks. 2. Mental shortcuts and traps. 3. The architecture of memory. 4. Why we forget. And finally, 5. How to remember better. Starting right off with Section 1, How Your Mind Thinks, or as I like to call it, the categorization machine. Okay, so cognition is basically this giant umbrella term for all the mental processes involved in knowing, remembering, deciding, and problem solving. It's the whole shebang. But to handle the absolute chaos of the real world without completely burning out, your brain creates what we call schemas. Think of a schema as a mental blueprint or a folder for a specific situation. For example, you have a restaurant schema. When you walk into a brand new restaurant, you don't have to relearn how the entire concept of dining out works, right? You already know you're going to wait to be seated, look at a menu, order, eat, and then pay. Because of this mental framework, your brain saves a massive amount of energy. You just roughly know what to expect. But what happens when these mental folders hit something totally new? Well, our minds update them in two very distinct ways. Picture a toddler who knows exactly what a dog is. That's their existing schema. One day, they're at a zoo and they see a wolf. If they point and yell dog, that is assimilation. They're basically cramming this new, fuzzy, four-legged creature into their existing mental folder for dogs. But once they learn that a wolf is actually wild and, quite different, they have to use accommodation. The old schema just doesn't work anymore. They literally have to alter their mental structure and build a brand new folder for wolf. So assimilation fits data into what you already know, while accommodation actually changes what you know to fit the new data.
Moving right along to Section 2, Mental Shortcuts and Traps. Essentially, the glitches in the matrix.
The wild thing is, the very same shortcuts that make our thinking so incredibly fast can also lead to highly predictable errors. When it comes to solving problems, your brain basically has two gears. The slow gear is an algorithm. This is a step-by-step procedure that 100% guarantees a correct solution. Think of doing long division on paper. It's systematic, it's totally reliable, but man, it is exhausting. The fast gear is a heuristic. This is a quick mental shortcut. If you're walking around a new city and you just pick the busiest restaurant because you assume a big crowd equals good food, you're using a heuristic. You didn't interview every chef in town, right? You save time and energy. But unlike algorithms, heuristics do not guarantee the right answer, and relying on these quick shortcuts leads us right into some classic mental traps.
Let me ask you a question. Have you ever sat through just an agonizingly awful movie simply because you'd already watched the first hour? Or maybe you forced yourself to finish a terrible book just because you spent $20 on it. Why on earth do we do this to ourselves?
Yeah, the reason we do this is a sneaky little mental trap known as the sunk cost fallacy. We are absolutely terrified of feeling like we wasted an investment, whether that's our time, our money, or our effort. So we drag out a bad choice just because of what we've already put into it. But biologically and logically speaking, that hour of your life is gone whether you finish the bad movie or not. A truly rational decision focuses strictly on what happens next. Is the remaining hour actually worth your time? If not, literally, just turn it off. Which brings us to Section 3, the architecture of memory. And spoiler alert, it is absolutely not a video recording.
Listen, if you take away just one single thing from this entire explainer, please let it be this. Your memory is a highly active working system. It's not a permanent storage bin where files just sit there perfectly untouched. Psychologists often map this out using the Atkinson-Shiffrin multi-store model. Step 1 is sensory memory, a super fleeting, momentary record of sights and sounds. It's kind of like the fading trail of a sparkler. If you actually pay attention to it, it moves to Step 2, short-term memory. This is your mental workspace, where you hold info briefly. Imagine holding a two-factor verification code in your head just long enough to type it in. Finally, with enough rehearsal, it moves to Step 3, long-term memory. This is your durable storage. But remember, just because something makes it into long-term storage doesn't mean it's perfectly accurate or even easy to find later.
Now, inside that long-term storage, we're actually running two entirely different systems. Explicit memory is the knowing what. It's completely conscious.
If you tell me exactly what you had for dinner last night or state a historical fact, you are deliberately pulling up explicit memory. Implicit memory, on the flip side, is the knowing how. This is memory expressed through performance and skills. Think about typing your password on a keyboard or riding a bike. You don't consciously think about the location of every single key or pedal, your body just sort of knows. Your past experience is driving your behavior without any conscious recall.
And here is where it gets really wild, because this framework fundamentally changes how we view truth. Enter constructive memory. This means that every single time you pull up an explicit memory, you are actively rebuilding it from scratch. You aren't hitting play on a video file. You are assembling a puzzle. Your mind combines stored fragments of an event with your current expectations, your schemas, and even things people told you after the fact. This is exactly why two completely honest people can witness the exact same event and remember it entirely differently.
All right, let's look at Section 4, Why We Forget, the Natural Decay of the System. So, our mental system definitely has some natural decay and glitches, but forgetting isn't always just old memories slowly fading into the abyss. A lot of the time, it's a fierce competition. When memories clash, it's called interference, and the direction of that clash really matters. Proactive interference is when old information blocks the new. You know, when you change your computer password, but your fingers just keep typing the old one? That's proactive. The past is moving forward and bullying the present. Retroactive interference is the exact opposite. You memorize a brand new phone number and suddenly you completely blank on what your old number used to be. The recent stuff reaches backward and wipes out the old.
Then there's source amnesia, which is honestly so incredibly relevant in today's digital age. This happens when you remember a really surprising fact perfectly, but you have completely lost the origin. Did you hear it from a trusted professor, a documentary, or just some random social media post? The actual content retains its feeling of familiarity, so you trust it, but the source is completely detached. This glitch explains perfectly why repeated claims, even entirely false ones, eventually start to feel trustworthy just because they feel familiar.
Okay, final stretch, Section 5, How to Remember Better. Let's talk about actually hacking your cognitive processes. So we know how the machine works, and we know where it glitches. How do we hack our own minds to make sure we actually retain what we want to learn? Well, here is your evidence-based toolkit. First up, chunking. Your short-term memory has super limited space, so group separate pieces of info into larger, familiar chunks, like breaking a random 10-digit phone number into 3 smaller digestible sections. Second, the spacing effect. Literally, stop cramming. Distributing your study sessions over several days allows some natural forgetting to happen, which then forces your brain to rebuild and actually strengthen those neural pathways. Third, elaborative rehearsal. Don't just blindly repeat a fact. Connect it to something you already know. Give it personal meaning. Finally, the testing effect. Self-quizzing absolutely crushes rereading because it forces the brain to actively hunt for the information.
To really grasp why that self-quizzing works so well, just look at the difference between recognition and recall. Recognition is just identifying information when it's placed right in front of your face, like picking an answer on a multiple-choice test. It's easy, right? The answer itself is a massive visual cue. Recall, though, that's bringing stored info to mind completely from scratch, like staring at a blank page for an essay. Recall is way harder, but forcing your brain to practice that struggle is exactly what builds bulletproof, long-term retention.
And the one master-level skill that ties this entire toolkit together? Metacognition. It literally just means thinking about your own thinking. It's the ability to monitor what you actually know versus what just feels familiar. Someone with high metacognition can step back and say, hey, I've stared at this textbook page 3 times and it feels super familiar, but if I close the book right now, I can't recall a single concept. I need to change my strategy. Which leaves us with one final, pretty important thought. You essentially possess the user manual for your mind now. You know how schemas organize your reality, how heuristics can trick you, how memory is reconstructed, and the exact strategies to encode information deeply. But none of it matters without awareness. So my challenge to you is this. Are you using metacognition to evaluate your own learning habits right now? The next time you sit down to learn something new, don't just go through the motions. Hack the system. Build a better mind.